Hi, today we are going to be talking about radians. So first let's see what is a radian. So basically the angle in radians would be the ratio between the arc length and the radius. So if we have this angle, so this is theta, the angle, and this would be the arc length A, and this would be the radius R. So the angle in radians is the ratio between the arc length and the radius. Now let's see how we can convert from degrees to radians. So if you want to go from degrees to radians, you need to multiply it by pi over 180. So for example, maybe let's give an example for the radians in the beginning. So let's say the radius is 2 centimeter and the arc length is also 2 centimeters. So the angle in radians would be 2 centimeter over 2 centimeter. So this would be 1 pi. So this angle would be pi if A and R are the same. So to convert from degrees to radians, you would multiply by pi over 180. So if you have 90 degrees, you would multiply it by pi over 180. But then you would just leave this pi, you would just leave this as it is. So it'll be pi over 2. So 90 degrees is pi over 2 radians. Now if we want to go back from radians to degrees, you would multiply it by 180 over pi. So for example, if we have, let's keep the same thing, pi over 2 radians multiplied by 180 over pi. So this would cancel out. As you can see, you get 90 degrees back. And some more things are, some more terms. There's something called the coterminal angle. So the coterminal angle would be angles with the same terminal arm. So for example, if we have this angle, this angle, and we have this arm, so coterminal angle would be, for example, this angle, since it ends up in the same place. Like you would start from here, if you go like this, you get the same thing. So it's coterminal angle, and they have a difference of 360 degrees. Now there's something called the principal angle. So the principal angle would be the the positive angle to which you will reach the arm. So for example, if you have this angle, this would be the principal angle, but this would not be the principal angle because this is negative. So for the principal angle, you would need to go positive angle. Now a reference angle is basically, so if you have this as the x-axis, this is the y-axis, and so you have this circle. So the reference angle would be the smallest angle between this arm and the x-axis. So this would be the reference angle over here. And over here, this would be the reference angle. Not this, because you need to measure from the x-axis. Now let's do a sample problem. So a satellite makes a complete revolution of the Earth in 90 minutes. So the time is 90 minutes. And so let's say this is the Earth. Say this is the Earth, and there's a satellite which makes a complete revolution around the Earth. So they've given us the time as 90 minutes. It takes 90 minutes for the satellite to go around the Earth. So they're saying that it is located 280 kilometers above the equator. So from here to here is 280 kilometers. And the radius of the Earth from here to here is given as 6,400 kilometers. So if we use the formula theta equals a over r, so the so we know the theta because it makes a complete revolution. Theta would be 360 degrees or 2 pi, and we know the arc length because the arc length would be, oh no, we don't know the arc length, so we need to find the arc length. So but we do know the radius of the whole circle. So the radius of the whole circle, you would have to add just the radius of the Earth, 6,400 kilometers. You would have to add it to the height of the satellite, because you want this entire length. This is r. So this is 6,680 kilometers. So now you know r, you know theta. So they want us to find the speed of light. So the formula of speed is distance over time. So we know, so the distance is a. We don't know that. So and the time is given to us. This is the time. So if we want to find a, we will go theta r. So theta is 2 pi, and the radius would be 6680 kilometers. So with this we get, in this case you would need to multiply by the pi also, and you would get 41971.67785 kilometers. So now you know a, so you can find the speed now. So speed is the distance, which is a, so 41971.67785 kilometers, and the time was given as 90 minutes. So, but we want it in kilometers per second, as it asks for kilometers per second, so we need to convert it. So to convert it, we can use a factor, the conversion factor of, so 1 minute is 60 seconds, so the minutes will cancel. And so you can put this into your calculator and you would get around 7.77 meters per second. So let's see if they want any rounding. So they want us to round to the nearest 100. So I have already done that. So the final answer would be 7.77 meters per second. Kilometers per second. My bad. So that's it for today. Thank you.